Alright, this is Mr. Gillum, and today we're going to be looking at the answer key to your interim assessment. This is kind of like your study guide for your Unit 2 test. So anything that's on here is going to be important for you to know for your Unit 2 test. Number 1 says that Randy has a party-sized sandwich that is 3/4 yards long. She will cut it into smaller sandwiches that are each 1/12 of a yard long. Which expression can be used to determine the number of smaller sandwiches Randy can cut? So I'm going to model this, and it doesn't say to model, but I just want to kind of show you how this works again because it's been a while since we've modeled. So if I call this 0 and I make a model, I'm going to call him 1. None of the numbers in this specific problem are greater than 1. So I'm going to divide this unit up into two different ways. The first way I'm going to divide it up is in 3/4. The second way I'm going to divide it into fourths. The second way I'm going to divide the same unit is going to be into 12ths. So I'm going to try to do my best to do that accurately so that we have a good model here. The top line we're going to do into fourths. So go like this. That should be close at least. So we have 1/4, 2/4 or 1/2, 3/4. And I know that this is how long my sandwich is right here. That's exactly how long it is. Now I'm going to divide the bottom number line up into 12ths. And so in order to do that, I think about how many fourths are in 12ths. So if I made each of these 3 pieces, 6 pieces, 9 pieces, 12 pieces. So if I divide each one of those marks for my 1/4 into 3 parts, I'll have 1/12 pieces because it will take 12 pieces to get to a whole. So that's what I'm going to do next. And each one of these marks represents 1/12. Okay, so 1/12, 2/12, 3/12. There's 3/12. 4/12, 5/12, 6/12, or 1/2, or 2/4, 7, 8, and 9/12, and then 10, 11, 12/12. So, or 1, of course. Now the question asks, if we have 3/4 of a sandwich, or a sandwich that's 3/4 of a yard long, how many 1/12 pieces could we have? So I could actually solve this by saying, okay, well, I need to know how many pieces there are, and this much, how many 1/12 pieces there are, and we can see very clearly that there's not 9/12 of a piece, there are 9 1/12 pieces. So we would say that there are 9 pieces. So one way we could approach this problem is by solving A, B, C, and D, or simplifying A, B, C, and D, and see which ones actually represent 9 pieces. And I think I'm going to do that just because I know that we need a little bit of review for how division of fractions and multiplication of fractions works. So 12/1 divided by 3/4. When we're dividing fractions, we think about keep, change, flip. And I know that's just a little like kind of a rhyme to remember how to divide fractions, but 12/1, change division to multiplication, flip the second fraction, and we can multiply straight across or we can cross reduce. This is 48/3. 48 divided by 3 is 16. That's not the same as 9, so I don't think A is a good choice. We can do 4/3 divided by 1/12, which is really 4/3, keep. Change the division to multiplication and flip the second fraction, 12/1. And again, we get 48/3. I don't think that that's a good choice because I know there should be 9 pieces. So I don't think B is a good choice. Let's try C. C says 3/4 multiplied by 12/1. And so that actually represents 36/4, or 9. So I do think that choice C would be a good choice. And I can also multiply 3/4 by 1/12 for choice D. And when we multiply, of course, we go straight across. 3/48. That's not a reasonable answer. 3/48 of a piece. No, there's got to be some pieces of 1/12 long in a 3/4 foot or yard piece. So C is our only choice. That makes sense to the actual solution. That's one way you could solve this problem. Another way would be to just think about if I want to know how many 1/12 fit into 3/4 because each 1/12 represents 1 piece, then I could say, okay, immediately when I think of this, I think of it as a division problem, 3/4 divided by 1/12. But really we know that 3/4 divided by 1/12 is the same as 3/4 multiplied by 12. over 1. The keep, change, flip method. So that would have been a much quicker way to solve choice C, but all these things that I touched on are going to be parts of what you may see on your unit test. So I wanted to make sure we talked about how all those things different worked. Number 2 says a scientist recorded the top flight speed of 2 peregrine falcons. One flew 306 and 87 hundredths kilometers per hour, and the other flew 298 and 59 hundredths kilometers per hour. What was the difference between their two speeds? So one of the things that sticks out to me right away is that the word difference, that indicates subtraction. And so we want to know the difference between their speeds. We need to take the larger number and subtract the smaller number from the larger number. So, of course, if I just use my estimation skills, I have about 307 and about 299. So I know that that's just 8. So my answer should be somewhere around 8 if I'm finding the difference between their speeds. So right away I know choice D is probably not a great choice, and I know choice C is probably not a great choice. And this is a strategy that you need to start becoming familiar with. If we just think about how reasonable the answer is, we can eliminate different choices, and that's a very, very important skill for when you're taking important exams like the PARCC test or later on the ACT. That'll really impact what kind of college you get into and those types of things. So just considering the reasonableness of your answer is a great way to eliminate some of the answer choices. So that was just an estimate to determine reasonability. Now let's actually solve what 306 and 87 hundredths and the difference of that in 298 and 59 hundredths. So on this problem in particular, I'm going to have to do some borrowing. We talked in depth about borrowing in my class. When I subtract, you see that in this case I have to borrow from a 0, and I think it was intentionally put on here that you had to borrow from a 0. I need to borrow from the 3 to have 10s to borrow for my 1s. So you can either think of this as I'm going to borrow from the 3, make it a 2, change this to a 10, borrow from that, make it a 9, and make that a 16 by borrowing 10 from the next place. Or you could think of that as 30 and just cross it out and put 29. It really is the same exact thing. So it'll save you a step if you just think of that. If the 0 doesn't work, think of it as 30, make it 29, and you can see it's the same exact thing. So 8, 0, 0. When we add or subtract decimals, we move it straight up and down vertically. 8 and 28 hundredths is what I'm calculating, so I know that's a reasonable answer, so I'm going to choose choice A. That is the difference between the two speeds. Sometimes students can be confused about when to count the number of decimal places behind in our initial problem. That would be 4. That's for multiplication. Okay, so not addition and subtraction. With addition and subtraction, we want to make sure that our tenths are added with tenths, our hundredths are added with hundredths, and so if we have extra numbers or not enough numbers, we can put zeros in as placeholders. It says, which point is the image of a point R, force -7, first reflected across the x-axis and then across the y-axis? So a couple things that you might want to write down to remember is if we reflect across the x-axis, x stays the same, and then we want the opposite of the y-coordinate. Okay, x stays the same. If we're reflecting across the y-axis, the x is the opposite of the value, and then the y stays the same. So what I mean by that is this. If I'm starting at the point 4, -7, and then I am first reflecting across the x-axis, so when I reflect across the x-axis, the x value stays the same, the y value becomes the opposite. So reflect across x-axis, what's going to happen is that point is now going to be the same for the x value, 4, and the y value will be its opposite. So we currently have -7, which was down 7. Now we want to be +7, up 7. So now after our first reflection, we are now at the point 4, 7. Our second reflection is across the y-axis. So this is a reflection across y-axis. Next. when we frict across the y-axis, the y value stays the same. In this case, now we have the point with a 7 in the y-coordinate, and the x value is now the opposite. So instead of being 4 to the right in the positive direction, we are now 4 to the left in the negative direction. So after 2 reflections, we should be at the point -4, 7. Okay, so that's how that works, -4, 7. Choice D. So you can see they're going to try to throw you off with all the different types of positive and negative 4s and 7s and all the orders and all that stuff. So that might be a good question to study and make sure you understand. These are 2 important points right here. X-axis, X stays the same. Y-axis, Y stays the same. It says Priscilla's perfect pie factory uses a scale to reject pies that are more than 3.2 ounces from the target weight of 28 ounces. The factory scale is calibrated to show how close a pie weighs to the target weight. So first of all, before I read anything else about how this problem works, what I'm thinking initially is that if the pie is more than 3.2 ounces heavier than 28, it's no good. If the pie is less than 3.2 ounces away from 28, it's no good. So our boundaries would be if we're supposed to have 28 ounce pies, if I add 3.2 to 28, I know 31.2 is one of my limits, and if I take 28 and I subtract 3.2, I see that the pie could weigh 24.8. So the pie must weigh somewhere between 24.8 ounces and 31.2 ounces. So the scale will display, okay, so it looks like we're talking about just understanding of positive and negative numbers. Positive number if the weight is over 28 ounces, okay, so if it's 28, 28.1, 28.2, it'll be positive because it's more than 28. It'll display a negative number if the pie is less than 28 ounces, so negative 3.2 would be 24.8. Oops, I don't know what I just did there, sorry about that. This would be a negative 3.2, and that would represent a weight of 24.8. It says 0 if the weight is exactly 28 ounces. Yeah, because it wouldn't be more or less than 28, so it would say 0. So that's how the scale is calibrated, as an initial starting weight of 28 ounces. If it doesn't quite make it at 28, it'll say negative number. If it's more than 28, it'll say a positive number. Which pie will be rejected by the scale? Select all that apply. Okay, so when I look at choice A, a pie with a reading of negative 2.8 ounces. This is actually, we need to consider about distance. So the distance from 28 of negative 2.8 will be 2.8 ounces. So we are still within the bounds of 3.2 ounces. The distance, which 3.2 represents the distance away from 28. So it has to be within that distance, and 2.8 is within that distance of 3.2. So that one would not be rejected. That one is okay. So we're looking for the ones that are being rejected. It says a pie with a reading of 3.5 ounces. Okay, so the distance of 3.5 away from 28 would be 3.5 ounces. And unfortunately, we have to be within 3.2 ounces. If it's 3.5 ounces over, then we would be at 31.5, not 31.2. And 31.2 is our cutoff. So I know that it would be rejected. B would be a choice that I would choose, that would be rejected. If the pie said negative 3.3 ounces, that means that it is a distance of 3.3 away from 28 ounces, and that's an issue because it cannot be more than 3.2 ounces away. And if it's 3.3 ounces away, instead of being 24.8, it would be 24.7. That's an issue, so this would be rejected as well. And then finally, a pie with a reading of 28 ounces. Okay, if the scale is reading 28 ounces, that means that because it is calibrated, where does it say that at? It's calibrated to show how close it is to the target weight. So if it's reading 28 ounces, the pie is actually twice as large as it's supposed to be. So definitely way bigger than what it's supposed to be. That's definitely not a good choice. Okay.